The most crucial part of this build, the thing that will actually make this car work, just arrived a couple days ago. I've mentioned a handful of times that we're gonna be getting a CNC machine, and it finally is here. This isn't some crazy large industrial machine that takes up half of a garage, but it's big enough and capable enough to do what we need to do for the few parts that we need for this car. I'm not gonna go too in depth on this machine. There's plenty of videos about them, about CNCs in general, about this specific machine, but I got too excited when I got here a couple days ago, and I went ahead and made a part on it. I knew it was gonna take some time to figure out some of the software and stuff, so I went and just sat down and worked on it, and we have our first part. First part I made are the little adapters for the bottom of the GTR knuckles. Here's the, that's a 3D printed version we have, and they're, you know, the same. This is a huge upgrade from the 3D printed stuff because it can actually hold weight. And most of these parts aren't gonna need to be steel. Like aluminum is gonna be fine for them. So finally having a piece that I know, this could be the final piece that goes on the car. This could be what takes it to Mustang Week. Not even a stronger stainless steel or steel piece. This could be the part that ends up on the car. And this machine made it. Also, look, this is just satisfying. How it's just such a tight fit. It's literally a perfect fit. Anyways, but finally having a machine that can make 90% of the parts that we need for this thing for it to become an official rolling car that can roll and steer and not break is incredible. It also fits on this part really well too. It just slides on. I said that now, it doesn't want to go on. Anyways, you can see it's on there, it's flush. It allows us to put that bolt in there. I'll do that real quick too. There's that. It does stick up on the bolts in there because you need to clamp it down for the bolt to push through because it is a really tight fit, but it all works. This is what's gonna adapt it to those lower control arms. So that's crazy cool. Again, nothing we haven't seen before. We've had the aluminum, we've had the 3D printed stuff. This potentially being the part that makes the car work and is on the car is just, it's insane that I designed this and did this in my own garage. I decided to bolt the whole thing together to show you guys what it looks like. That's pretty cool. I just filmed a whole section about some other updates on the car. Before we get to that, we have a project with the CNC. Anybody who wants to see this, I'm gonna show you guys this first. So, the project that we have is some of these adapters that I've showed you guys before on the spherical bearings are too large for the smaller bearings in the upper control arm. If you notice, this one isn't set all the way down in there. It's just kind of sitting there and I have it just bolted on. I need the inner diameter to be the 5/8, but I need this to be, I think it's 17 millimeters. Currently, this right here is 19, so I have to turn that down to 17. Now we don't have a lathe, we have a CNC machine. The plan here is gonna be lock this in place. We kind of have to trick the program to know what size piece is there because I can't tell it that this piece is in here. I have to tell it that there's just a rod of metal in there. So I have to trick it in a slight way, but then we'll just tell it we'll make a model and tell it to turn that piece down to the right size to 17 millimeters. And for a little bit, it'll just kind of spin in the air and then it'll start contacting that area. So we're gonna try to make this because they don't make the 17 millimeter with the 5/8 hole in the middle. I don't think it's gonna have any structural problems. They're not really, this piece, all it is a centering piece inside the thing. We honestly probably could cut it off, but I'd like it to be a little bit more official than that. So we're gonna try to do that. It's funny that we're already having to trick the thing into doing what we want it to do versus just loading up files, but that's the name of the game. Same thing with 3D printers. Sometimes you just have to trick it into what you want it to do. But I'm gonna work on the programming for it and then we'll load it up and see how it goes. And hopefully nothing breaks. Okay, I stopped the machine because I didn't want it to go for like 2 more hours and then have it be wrong. So if you come look at here, it's cutting off center. But again, this is not exact. I had to trick it to like get it to probe the right points to level it. So it's cutting off center, but I think that'll be okay. And actually it does fit in there. So I'm gonna restart it and let it go and let it cut all the way down. But for now, I think proof of concept, it works. And worst case, we'll do the opposite. We can actually get the ones that fit in here and then cut out the outside for the 5/8 bolts. So if these end up breaking or snapping, again, we can honestly cut it off and just have it be the tapered piece. There's 1,000 ways to do it. So, but this is working. CNC is good. Now we're gonna jump back in time and I'll show you guys the updates on the rest of the car. I think I had this clutch last video, but I didn't show it. I'll have to go back and make sure I didn't already show it. But this is the clutch disc we'll be using. So compared to a regular clutch disc, it obviously has the right splines for the GTR transmission, but it doesn't have that center hub with the springs in it, and it's a different material. Now, what this clutch does is it's more of like an instant on clutch. You don't get to ride the clutch as much and get little movements. It's usually either on or off. You get very little wiggle room to engage the clutch and have just little like in traffic movement. On top of the extra forces that come with it, because again, there's no springs in this hub. It is just straight connected. Those springs usually take up a little bit of vibration and dampening where the clutch engages. This does not have that. It's also a different material. It's not that like fiber material. It's like a, I guess more of like a brake pad material, but I think even more aggressive than that. But it fits on our splines just fine, so that's all we need. It is a little bit smaller. I could only find, the only clutch I could find with that spline that was large enough for us. The normal Mustang clutch is 10.5 inch. This is a 10 inch. I think I mentioned that before. This was the largest one I could find. It's not, you lose a 1/4 inch around the whole thing. But it's such an aggressive clutch, I think we'll be fine in terms of how much power we're running. I don't think it's gonna slip. Along with the clutch comes a new adapter plate. So if you guys remember, the plate that we had, this adapter plate. So this was like 1 inch thick and had the countersunk holes and had all the cutouts and everything. It didn't work. That's for a couple different reasons. So first of all, you see these holes back here? These are all the cutouts for the bearings on the GTR side. These just kind of hold the bearings in place. I mean, the bearings are already held in place on the shaft, but it just adds extra support for all the forces on the input shaft. And then down here, the same thing. There's a lower bearing as well. Those are too close together. I messed up the measurements on that, and they're just too close. And then also the width of it has to be shortened. When I went to design the transmission plate, I was only accounting for how far I had for the input shaft to go into the back of the crank where the pilot bearing's at. Did not take into account how far the splines are on that shaft away from the motor. So when I had the input shaft resting in the back of the pilot bearing, I was like, oh, we have plenty of room. Not realizing the splines were way too far back and wouldn't engage the clutch at that distance. Just for a better example, if you put, actually that's the line I made right there. If you put the input shaft into the pilot bearing that far, the flywheel only goes to like that next ridge. So you had like all this room that the clutch, there was just gap. The clutch couldn't go any closer and still be engaged with the splines. What that means is we have to shorten the adapter, which we have room for, and I think we still need to shave off some of the bell housing. I can only go so thin on this plate. I went from 1 inch to 1/2 inch. I took half of it out. We even had to go to different bolts. We had to go to the actual like V countersunk bolts versus the socket head bolts with a countersunk hole. Not something I wanted to do, but if we have to do it, we have to do it. And the other head, by the time you made room for the head of the other bolts, you only had like a couple millimeters of material behind it to actually clamp onto. With aluminum, that's just not gonna work. Steel, I'd be fine with it, but aluminum, I even had to get specialized bolts. Really short, I wanted as much material behind it as possible, so I got specialized short countersunk bolts. We need 9 of them. The bolts were $10 a piece. The only ones I could find were like stainless steel, high strength bolts. So $90 in bolts for this. But on this is a new adapter. I fixed the holes on the back, so it's a little bit farther away, I think, on this one. No, actually this one is still wrong. This one is just thinner and has the countersunk holes. So we're still waiting on one of those to be printed as a mock-up, and then I think, well, I have to do some weird wizardry in the CNC because it's a little too big for it. So I have to like put it in there, let it cut like that, then flip it and let it cut that, and then 180 and then do the same thing. I think we can get it done. Next thing I did for the car was I cut a hole in our bell housing. Now what this hole does is allows this is exactly where the drive shaft needs to go through to hit the front diff. It also is where our starter goes, so we have to move the starter somewhere else. I tried moving it to the other side because we won't have a clutch fork or anything like that. We're gonna go with some kind of hydraulic system for the clutch. My next thought is cutting out a window up here and bolting something off of these 2 bolts that like kind of comes out and then mounts. It's gonna be difficult. I'm gonna be honest. The first time we go to test this car is probably gonna have to be push started. Not ideal, but if I wanna get the 4-wheel drive working and tested, that's what we're gonna have to do. Obviously, I would much rather buy a different bell housing and throw a starter on it and not have the 4-wheel drive and get it down to the beach. But if we're going all-wheel drive and we need to do some testing, it will just have to be what it is. Designing starters and starter locations is really complicated because you have a certain engagement with the teeth where a starter, when it's just sitting idle, is like pulled back in, and then it has to when you turn the key, it pops out and it has to spin and engage a certain amount so it doesn't grind. It's a whole thing. Not easy. Not that really any of this has been easy, but this is really the only spot that it's gonna fit. So yeah, gotta figure that out next.